Now let us solve this problem. In order for us to be able to solve this problem, we need to consider the statement carefully. It is very important to do so because a statement makes us understand what we are dealing with. So let's read the statement. The statement tells us that crate P of mass 1, 2 is connected to another crate Q of mass 2 kg by a light inextensible string. The two crates are placed on a rough horizontal surface. A constant force F of magnitude 7,5 newtons acting at angle theta to the horizontal is applied on crate Q as shown in the diagram below. The crates accelerate at 0,1 meters per second squared to the right. The following diagram then gives us a picture of what our statement has said. We are then told that crate P experiences a constant friction force of 1,8 newtons and crate Q experiences a constant friction force of 2,2 newtons. Before answering the questions, let us consider carefully what we are given and also discuss where will it help us. The first two things that our statement gave us is the masses. Mass for crate P, which can be represented by MP or M1, and mass for crate Q, which can be represented by MQ or M2. A statement then gives us an applied force at crate Q, which can be represented by FQ or presented by F applied. It should be noted that this applied force we are given, which is 7,5 newtons, is only acting at crate Q. An applied force for crate P is different. An applied force at crate P is through our string, and this applied force can be presented as Fp or a tension force. And according to the statement we have read, we are not given this tension force or this force applied at P through our string. We are then given acceleration for both crates P and Q. A statement underneath our diagram add two more things: friction forces, friction force at P and friction force at Q. Friction force at P can be presented by FRP or FR1, and friction force at Q can be presented by FRQ or FR2. Now that we have carefully considered what the statement says and every information that we are given, we are now ready to consider the questions. Let us now do our problem between black and white. By that I mean, let us now do every calculation or answer every question on this white sheet. The first question requires us to explain Newton's second law. So I will not write the definition as the textbook does. I will just tell you the important things to mention when you are answering that question. Newton's second law of motion speaks about the resultant force, which can be also be called a net force. So what it says is, when this force is applied to an object, let's say this is our object, an object can be anything. It can be this calculator, it can be this pen, this paper, it can be anything. So when we apply a force F net on it, on this direction, this object, what will happen to it? It will be pulled to this direction. So instead of saying it will be pulled or it will move to this direction, the law says it will accelerate. So don't say whenever a resultant force or net force is applied to an object, it will move. Say it will accelerate. On which direction? On the applied force direction. But what happens when our applied force is on the opposite direction? The law makes it simple. It only speaks about the direction, not left and right, up or down. It will still, this object will still move or accelerate to this direction. Since a resultant force is calculated by MA, there is a relationship of acceleration. The acceleration has a relationship with the force itself. It also has a relationship with the mass. So how would we calculate acceleration? Our acceleration would be calculated by A equal to our resultant force divided by m. So what will happen if we increase the resultant force? The acceleration will increase. If we decrease the resultant force, our acceleration will decrease. So you see the relationship. It's directly proportional. So our force is directly proportional to acceleration. But what happens if we decrease and increase the mass? If we increase the mass, our acceleration decreases, because we'll be dividing here with the bigger number. That is why our acceleration decreases. But what happens when we increase the mass? When we decrease the mass. Once we decrease the mass, our acceleration increases. So now the relationship between acceleration and mass is inversely proportional. So those are the things that you must not forget to mention when you are explaining Newton's second law, is that when a resultant force or a net force is applied to an object will move to the direction of the applied force or of the resultant force or net force. And you must also tell us that the acceleration is directly proportional to a force, or force is directly proportional to acceleration, and mass is inversely proportional to acceleration, or acceleration is inversely proportional to mass. So that's how you would explain that. Let's come to 2.2. To 2.2, they said we must draw a free body diagram of crate P. So crate P is here, and we know that we have a normal force and the gravitational force. It should be noted that these arrows must be equal, because when one arrow, like me here, this one is long and that one is short, this means we are going down. So when you do that, you're not using your free hand, you take your measurements carefully. And we also have this force, which can be called a tension force, or you can say a force on our string. We also told that we have a friction force. We know a friction force is always opposite to the applied force. And if you want to, you say FRP or FR1 to present or to show that this force is on crate P, which is our first crate from the left. So you would be done, but make sure that you tell them that this is your normal force, and this is your gravitational force, and this is your frictional force, and this is the tension or the force on a string. On the third question, 2.3,1, we are asked to calculate the tension on our spring. So for us to calculate the tension on our spring, we need to remember some few things concerning this force, and such things are the same things that we penned down when we were drawing this free body diagram. What are those things? The tension force is to the right, so it's positive. The friction force is to the left, so it's negative. We must remember that since this object is moving horizontally, this means that sum of the forces on our horizontal direction is equals to MA. If you remember what is happening on some of the forces on our vertical x-axis, since this object is not moving up and down, the sum of the forces on our y-axis equals to 0. And the sum of the forces there, our normal force, is taking that direction and is positive. This one is taking this direction and is negative. Sorry, my camera didn't focus there. We said that the normal force is taking the upwards direction, and that makes it positive, and the gravitational force is taking the down direction, and this makes it negative. So if we were to expand here, we would say the normal force plus gravitational force is equal to 0, and this sign would change because this force is taking this direction, which is negative, and this would be n minus w equal to 0, which makes our normal force equal to the gravitational force. This is not asked, by the way. I'm just explaining it to you so that you understand what we're gonna do there. So now this is the formula we are gonna use since our object is moving horizontally. So let's use the formula. The formula says sum of the forces on our x-axis is equal to MA. How many forces do we have acting on crate P? We have two, the tension force and the friction force. This one is positive and this one is negative. So we will have T minus friction force 1. Let's use 1 equal to MA. Why this one is negative? When we said there it's the sum. I hope you remember that this is the same as T plus into minus FR1 equal to MA. So this sign changes this sign to a negative sign. So that's how we came to have this negative sign. So we would then substitute or transpose FR to that side. Let's transpose FR, sorry, and we would have MA plus FR, the friction force for crate P. What is the mass? It's 1,25. What is the acceleration? It's 0,1. And what is the friction force? Sorry, it's not times, it's plus. What is the friction force? It's 1,8. So our answer here would be what we will get just now, plus 1,8. This is 1,93 newtons. So we just decided to round off to 2 decimal places. The question paper tells us to round off to 2 decimal places or to round off to 3 decimal places. We listen to what our question paper says. Let us now come to the last question, which is 2.31. We are told to look for this angle. For us to get this angle, you must remember that we have a force here, and that force can be represented by Fx. We also have a force there, which can be represented by Fy. So remember that N was equal to W, and that force was not considered because we were dealing with this crate. Now we are dealing with that crate. But I would like not to consider that force to make things simple. So what are we going to do to calculate this angle? Our object is moving horizontal. We want to use everything that is horizontal. So how are we going to get this Fx when it's not given? You would remember trig ratios, cos theta being equal to adjacent over opposite, and sine theta being equal to this is adjacent, oh sorry, it's hypotenuse, and sine theta would be opposite over hypotenuse, and the tan theta would be y over x. That means opposite over adjacent, opposite over adjacent. So on this case, we want to use this one. We don't want to use that one. Why we don't want to use that one? If we use that one, for example, if we take this trig ratio, it makes us have two unknowns. We don't know the adjacent and we don't know the opposite. If we take this one, we know the hypotenuse and is 7,5. We don't know the opposite. If we take this one, we know the hypotenuse 7,5. We don't know the adjacent, but I said I want to take everything that is horizontal. So for us to get that, we will say cos theta equal to our adjacent Fx all divided by hypotenuse, which is 7,5. Then this makes our Fx equal to 7,5 cos theta. This comes and multiply here. I hope you see where is that coming from. So now we are ready to calculate I said 2.32. Sum of the forces on our x-axis equal to ma. And what is the sum of the forces? How many forces we have acting on that crate? We've got the friction force, which is said to be 2,2 newtons. We again have the tension force, which is the force through our string, and we calculated it to be 1,93. When you asked to draw a free body diagram, you must remember that on this case, the friction force is more than the tension force. So you would make an arrow for a tension force longer than the arrow for a friction force. Let us expand here because we know we have this force, and this force. So friction force number 2 plus the tension force plus Fx equals to MA. Now this one, it's going to a negative direction, this one to a negative direction. So this makes Fr2 negative and the tension force negative. And this one is equal to that. So we can replace it with 7,5 cos theta. And the mass is 2 times 0,1. Some students might make cos theta the subject of the formula, and some will just substitute. So let us help those who like to make cos theta the subject of the formula. This is what will happen. This will come to this side and this will come to this side. So they would then have 7,5 cos theta equal to MA plus T plus FR2. They would then divide by 7,5, then they would have cos theta equal to MA plus T plus FR2 all divided by 7,5. And they would have theta equals to cos raised to minus 1 all into MA plus T plus FR2 all divided by 7,5. So they would then substitute everything there. I bet you they will get the same answer that we will get here. So let's substitute here. Our friction force is 2,2 and it's negative. Our tension force is 1,93 plus 7,5 cos theta equals to, what is this? 2 times 0,1, it's 0,2. So these will add, right? So we will end up having minus the sum of this, and that sum will still be negative and then will be taken to this side and the sign will change and be negative and be positive. So this is the same as saying 7,5 cos theta equal to 0,2 minus 2, plus 2,2 plus 1,93. Let's add that on the calculator. 2,2 plus 1,93. It gives us 4,3. What we would do then here, we would divide both sides by 7,5. So let's divide there by 7,5. That is our answer. So we end up having cos theta equal to 0,577. Now we want theta, not cos theta. So we'd say cos 0,577. Then we would get theta. Let's see, let's store this in memory of A. Then let's say second function cos 0, let's recall A. What was the reason of storing? Then it's gonna be 54,74 degrees if we round off to 2 decimal places. Let us check what were the students gonna get when they just substituted everything on the formula that they have manipulated. They would say second function cos, and from there they would say what they would say. MA, they would say MA is 0 comma is 2 times 0 comma 1. 2 times 0 comma 1. Okay, they would put brackets for your calculator not to flip it up, and they would say plus the tension force, which is 1,93. They would add the friction force 2,2, and they would put 7,5. Brackets will be closed, then the answer would be exactly the same. So you take any method that seemed to be working for you.